Hi class, what I want to do in this lecture is I want to talk about translating verbal expressions into variable expressions. And what this is this is our first step into eventually solving complicated word problems in mathematics. So actually in this case today all we're going to do is translate problems, not actually solve anything really. Okay, so we're going to have three objectives in this lecture video here. I want to translate a verbal expression into a variable expression first. I want to translate a verbal expression into a variable expression and then simplify the resulting expression. And then finally, the last thing we're going to do at the end of the lecture is translate an application problem. Okay, so first translate a verbal expression into a variable expression. So what this is going to involve is actually like the use of keywords. So keywords give away how you translate a word problem into a mathematical expression. So one of the major skills required in applied mathematics is the ability to translate a verbal expression into a variable expression. This requires recognizing the verbal phrase that translate into mathematical operators. So what I have below is a partial list of phrases used to indicate the different mathematical operators. So for example, when you see the following words, these are synonymous with addition. Added to, more than, the sum of, increased by, the total of, plus. All these words indicate addition. Like when you see 6 added to y, that's saying take y and add to it 6. 8 more than x, add 8 to it, and so on. The sum of x and y, add them. These type of words signify addition. You can have these for subtraction. Some of the key words that you'll look for are things like minus, less than, less, subtracted from, decreased by, the difference between. This type of stuff tells us to do subtraction. Like when you see 7 less than t, that's saying 7 less t. I put a then in there, 7 less t, excuse me. 5 subtracted from d, you have to be careful on this one. You don't want to write this as 5 minus d because you're subtracting 5 from d, so it would be d minus 5. And you can follow the rest of these on your own. Multiplication, times, of, the product of, multiplied by, twice, 3 times, things like that indicate multiplication. So like for example, 1/2 of x. Of tells me to multiply 1/2 times x. B multiplied by 11, that would be 11b. You can see how these words translate to multiplication. All right, keywords for division. Divided by, the quotient of, the ratio of, these are things that signify division. So when you see something like the ratio of t to 9, that would just be t divided by 9. All right, here are some phrases for power. The square of x would be x squared. The cube of a, this would be a to the 3rd power. Stuff like the 5th power of y would be y to the 5th. Things like that signify when you're raising something to an exponent. Okay, so let's do some examples. Here's what I want to do. I want to translate into a verbal expression the following. The total of 5 times b and c. Okay, that's tricky. The quotient of 8 less than n and 14. Okay. 13 more than the sum of 7 and the square of x. Okay. Let's try this one here. First one. The total, okay. The total of, little typo here that says n, but it should be 5. The total of 5 times b and c. So the total tells me it's going to be a sum. So it's the total, so I put that there, sum, right? That's going to be an addition. The total of 5 times b, well that tells me multiplication, so that's 5 times b, and I'm c, so the c goes in the second part. So I'm telling you to take a total of 5b and c. So just translating it that way. Let's try this one. The quotient of, so the quotient tells me it's a division problem, okay? 8 less than n, so that's subtraction, less than n, so I'm taking 8 less than n, so that would be n minus 8, and 14. So it's the quotient, and the last part is 14, so the 14 goes on the bottom. Okay, let's try this one. 13 more than, so that tells me I'm going to add 13 to something. Okay, so what am I adding 13 to? The sum of, so I have to have some sum I'm adding 13 to. 7 right there, and the square of x. So I'm at the sum of 7 and the square of x would just be 7 plus x. So notice how in each of these cases I'm underlying the keywords that are telling me what mathematical operator to do. All right. So in most applications that involve translating phrases into variable expressions, the variable to be used generally isn't given. So to translate these phrases, a variable must be assigned to the unknown quantity before the variable expression can be written. So sometimes it'll just say something like quantity x, quantity squared, where they didn't say the variable. You have to assign the variable for that quantity. Okay, so let's try this one. Let's translate a number. So the number is what we're trying to translate, so that's the unknown. A number multiplied by the total of 6 and the cube of that number. Okay, so first off, a number. So the unknown number we will assign as just the letter n. You can assign it x, whatever you want. Cube of that number. Well, that's going to be n cubed. So it's going to be a number multiplied. So it's the number right here multiplied by the total of 6. So the total tells me to sum 6 and the cube of that number. So the total of 6 and the cube of that number is 6 plus n cubed. So it's the number multiplied by, and then you have to put in parentheses because it's multiplying by it, 6 plus n cubed. Okay, so notice they didn't tell us the n here, but we just assigned that value that way. Okay, so now let's translate a verbal expression into a variable expression, and then what we want to do is just simplify the resulting expression. So just a little bit extra step of simplifying. So after translating a verbal expression into a variable expression, what we want to do is we would just want to simplify this expression by using the properties of the real number. So get it in its simplest form, combine any common terms that there might be. Okay, so let's try this one. The total of 4 times an unknown number and twice the difference between the number and 8. Okay. So here we go. The total of, so an unknown number. So the unknown number is going to be just n. And what we have here, twice the difference of the number and 8. So let me go back. The total of 4 times an unknown number. So 4 times an unknown number is 4n. The next thing it says here is, we'll get to this, combining this together, twice the difference between the number and 8. So twice the difference. So the difference of the number and 8 in parentheses, and then twice it. So that's telling me to multiply it. So going back, the total tells me to sum. So we're going to sum 4 times the number plus, because we're summing it, twice the difference of the number and 8. So this is what it's translated as. But what we want to do now is we want to simplify this. So I think you can see how to simplify this. We're going to distribute the 2. So the 2 times n is 2n. 2 times minus 8 is 16. And then you have this 4n here. So we still got to simplify this. We have 4n plus 2n. Well, add the 4 plus the 2 gets me the 6n. So this ends up just being 6n minus 16. So we translated it, and then we just put it in its simplest form. All right, let's end by doing an application problem here, okay? So many of the applications of mathematics require that you identify an unknown quantity. We're going to assign a variable to that quantity and then attempt to express another unknown quantity in terms of that variable. Let me show you with this example. So the length of a swimming pool is 20 feet longer than the width, okay? So notice that I have the length and width here, okay? But what I want to do is I want to express the length of the pool in terms of the width. Okay, so I'm telling you to express it in terms of the width. So I'm going to define the width of the pool as the variable w. Then what you see here, it says the length of the swimming pool is 20 feet longer than the width. Well, then that means that the length would be the width, and then more, the length is 20 foot longer, so that tells me addition. The length is 20 more than the width, so that would be w plus 20. So now our length is put in terms of w. So even though I'm looking to find the length and width, It's actually only in terms of one variable, the w variable. All right, class, I hope this helped. And next, in the coming weeks, we'll work more problems and actually solve some of these word problems.